Continuing with hydrogen, it is our fourth lecture on hydrogen. Question is, what are hydrides? Discuss their types. So hydrides, these are the binary compounds of the elements with hydrogen. The hydrides, they are of many types. Number one, ionic hydrides. These are the compounds of hydrogen with more electropositive metals like sodium, calcium, etc. We have example sodium hydride, we have calcium hydride. So they are having ionic character, that's why they are called as ionic hydrides. We also have acetylene, sodium acetylide. It is also having some ionic character. Then we have covalent hydrides. These are the hydrides of non-metals. They are having covalent bond between the non-metals and your hydrogen atom. They are called as covalent hydrides. They are of following types. Number one, electron deficient. These electrons in these hydrides, central atom does not have complete octet. It is having less than 8 electron in its octet. For example, we have BH3 which is having 6 valence electrons around it. Similarly, ALS3 hydrides of your 13 group element, they are all electron deficient hydrides, and we have electron rich hydrides. These are the hydrides in which central atom has more than 8 electrons in its compound. SH6, this is called as sulfur hexahydride. Then we have electron precise hydride. These hydrides contain 8 electrons in their octet and are covalent in nature. CH4 is one such hydride, C2H6. All alkanes, they are this type of hydrides. They are called as electron precise hydrides. Then we come to interstitial hydrides. This is third type. These are the hydrides of transition metal, where hydrogen is fitted in the interstices of these transition elements. Because size of the interstices that matches with the size of hydrogen, that's why these hydrogen, they get easily fitted in the lattice of that your transition metals. So these hydrides are formed. Now we have the second question, uses of hydrides. They are used in the generation of compounds. Then we have question number 2, discuss 3 states of water in terms of hydrogen bonding. So water exists in 3 states. Number 1 is ice. It has 3-dimensional network of hydrogen bonded water molecules. And it forms cage-like structure. requires more volume and ice floats on water due to less density. Then density is equal to mass upon volume. Volume is more, therefore density will decrease in this case. So its structure of tetrahedral covalent network of water molecules. So these are the cage-like structure. Each oxygen is capable of forming 4 hydrogen bonds. 2 hydrogen bond and 2 covalent bonds are there. This is a 3-dimensional network of the water molecules. Water molecules are held together by means of hydrogen bond. So this is first form of water. Second is the liquid water. It has irregular hydrogen bonding between water molecules. Some of the hydrogen bonds from tetralink network, they have been broken, and water has this kind of structure. OH, O is negatively charged, held by the hydrogen of another molecule, and this goes on. This is no perfect arrangement of the water molecules. The hydrogen bonding may proceed in any direction. Then we have the third state of water, that is steam or gaseous water. It has no hydrogen bonding in water molecule. All water molecules, they are separate from each other. They can move anywhere. They have weak van der Waals forces among their molecules. Then we have very important question: why density of water is maximum at 277 Kelvin? As we saw, in case of the ice, there is 3-dimensional covalent network of the water hydrogen bonded water molecules, where each water molecule, it is having 4 hydrogen bond in this case. This is the reason why melting point or boiling point of water is higher than that of the HF, which is having only 2 hydrogen bond, which can form only 2 hydrogen bond, but in this case water molecule can form more hydrogen bond. That's why its boiling and melting point will be more than that of HF. Now we come to the density of water is maximum at 277 Kelvin. It is due to the reason that when we heat water or temperature of ice is raised, the covalent network of hydrogen bonds that go on breaking, and water molecules, they will start coming together. So volume of the ice, water change from the ice, it will go on decreasing. Therefore density will go on increasing. But up to 4 degrees centigrade it goes on. After 4 degrees centigrade, there is another tendency on the part of the substances or the liquids. When we heat them, they start to expand. So after 4 degrees centigrade or 277 Kelvin, the water molecules, they will start moving away from each other because of the more energy. So when they start moving away from each other, volume starts increasing, and when volume start increasing, the density start decreasing. So density is maximum up to 4 degrees centigrade or 277 Kelvin, because volume is minimum at that state. After that the volume start increasing, so density will start decreasing after this temperature. That's the reason that water has maximum density at 277 Kelvin, or you can say at 4 degrees centigrade. Now we come to another property, another important question: what is heavy water? Give its preparation. Now what is heavy water? D2O is called as heavy water, and it is formed from it is an oxide of deuterium. As we know, hydrogen has three isotopes: protium, deuterium, and tritium. The monoxide of deuterium, D2O, is called as heavy water, and it has been seen that ordinary water contains very less quantity of heavy water. If we take 20,000 liters of the ordinary water, only 1 liter of heavy water will be there. So this can be prepared by the electrolysis of ordinary water. When ordinary water containing some amount of NaOH it is subjected to electrolysis, then ordinary water evaporates, it goes off in the form of hydrogen and oxygen due to electrolysis, and the remaining volume after end of the process will be that of D2O containing traces of sodium ions in it. So this is the way how heavy water is prepared. So heavy water is D2O. It is prepared by electrolysis of ordinary water. So this ordinary water in the presence of NaOH ionizes to give you H2 plus O2 on electrolysis, having traces of D2O. So after complete electrolysis we have heavy water having traces of H2O and sodium ions. So this is the preparation of D2O. It is done by Urey 1932, who prepared heavy water by the electrolysis of the water. Now we come to the physical properties of the heavy water. It is heavier than ordinary water. Its molecular mass is 20. Its density is 1.106. That of ordinary water is 1 gram per cubic centimeter. Its melting point is 276.8 Kelvin. Its boiling point is slightly greater than water. It is 374.4 Kelvin. Now we come to the chemical properties. Chemical properties of D2O. Number 1, it has chemical properties similar to water. On heating it decomposes. On electrolysis it decomposes to give E2 and O2. D2O electrolytes. We get 2D2 plus O2. Then we have its reactions with metal. Similar to water, it will be producing alkalis on reaction with water. In water we were getting 2 NaOH, here we get 2 NaOD plus H2 D2 gas. Similarly 2K plus 2 D2O, you get 2KOD. So in this manner we are getting the deuteroxide on reaction with metals. So other property, they are similar to ordinary water. We are not going to discuss them in detail. Then we have the next question. Very important question. What is hardness of water? How many types of hardness you see? How it can be removed? How hard water can be made fit for drinking? So this is the main question. Question number 5. Define hard water. Discuss types of hard water. that sample of water which contains chlorides and sulfates of. It does not produce lather with soap. Since it contains chlorides and sulfates of calcium and magnesium ions, which produce precipitate with our detergents or the soaps. Mostly they produce precipitate with the soaps, and that soap is not able to perform its cleansing action. Now what is our soap? This is our soap, sodium salt of higher fatty acids. When it comes in contact with calcium, we get HCO twice Ca. These are the precipitates of the soap. Then we have RCONA treated with magnesium ion. You get RCO twice Mg. These are the precipitates of the soap. So, cleansing action not performed. And cloth will remain dirty. It cannot be cleaned. So, how this hardness to be removed? We'll see that. First of all, we see type of hardness. We have two types of hardness. Number one is temporary hardness. It is due to the presence of bicarbonates of calcium and magnesium. It can be easily removed. It can be removed by boiling. If we boil this solution containing these salts, they will decompose to give you CaCO3, water and carbon dioxide. CaCO3 settles at bottom, it is precipitated out, it is filtered out. Similarly, if you are having magnesium bicarbonate, it is also heated to give you MgCO3 plus water plus carbon dioxide. MgCO3 settles at bottom. So the water obtained by this method, that is a pure water. Second, by adding lime water. If we add lime water to this solution, that will also help in the precipitation of bicarbonate as a carbonate. You get 2 CaCO3 plus 2 H2O. So these are the precipitate which will settle at bottom. Similarly, we have MgSCO3 twice added with lime water. We get MgCO3 precipitate settle at bottom, CaCO3 precipitate plus water. So this is our salt water, and remaining part salts which are in the form of precipitate, they are taken out, they are filtered out and are thrown away. This method is also called as Clark method of converting hard water into soft water. Then after this we have the second hardness, that is called as permanent hardness. Number 2 is permanent hardness. It is due to chlorides and sulfates of calcium and magnesium. It is due to calcium sulfate, calcium chloride, magnesium sulfate or magnesium chloride. Now this hardness can be removed by, there are number of methods available to us. So we will discuss the removal of permanent hardness now. It can be removed by using inorganic salts, sodium metasulfide, and we can use the zeolites for the purification of the your hard water to remove permanent hardness from the water. We can do this. First, by adding washing soda to the above solution, we can remove permanent hardness. Removal of permanent hardness. Number one, by adding washing soda. So we add washing soda, that is Na2CO3. It will convert calcium into calcium carbonate, which settles at bottom, plus sodium chloride plus your water. So the calcium chloride and calcium sulfate, magnesium chloride, they all are removed as they are. Carbonates, which are insoluble in water, they are filtered out. So this is the first method, by adding washing soda to your hard water having permanent hardness. Then we have the inorganic ion exchange method. This is also called a zeolite method. In this method, we use three-dimensional silicates which are having formula Na2, Al2, Si2, O6, X number of water molecule. Since this is the active part, sodium is the active part of this salt, so we'll be using Z for this. It can be written as Na2Z. So this method is also called as permuted method. This zeolite is packed in a large glass vessel, and then hard water is added to this zeolite. It removes calcium and potassium ions as follows. Na2Z, it is three-dimensional silicate, reacts with calcium ion, produces calcium zeolite, sodium ions made free here. Similarly, Na2Z in permuted vessel combines with magnesium ion, giving you Mgz plus 2Na positive, they are free. Now it can be regenerated. Regeneration of zeolite. So what is CaZ? You add to it 2NaCl. You will be getting Na2Z plus CaCl2. Similarly, you have Mgz added with dilute NaCl solution. You will get Na2Z again plus MgCl2. So in this manner, the used zeolite, it can be regenerated. Regeneration के बाद it can be used again for purification of water. This is called as permuted method and is used to purify the compounds.